Hello everyone, this is Ray PCB, your trusted PCB partner. Today, we will be performing a schematic electrical check in KiCad. Schematic design is a preparatory step. Some beginners, for the sake of convenience, update the schematic directly to the PCB after drawing it, but this often leads to more trouble than it's worth. Following the design process for PCB design not only helps you develop good habits, but also effectively prevents errors in complex circuits. Due to software differences and circuit complexity, schematics may have issues like single-ended nets or electrical open circuits. If you proceed to production without checking with detection tools and discover problems after boards are made, it will be too late. Therefore, the compilation step for schematics is still very necessary. PCD comes with ELC function, which can automatically check certain electrical connection characteristics in the schematic. Any errors found will be listed in the electrical rule check panel and also marked directly on the schematic. Users can configure the checking rules and then use the error information listed in the electrical rule check panel to correct any errors present in the schematic. So let's take a look at the schematic we completed in the previous session. First, let's take a look at the settings panel. Here is where you configure the checking rules, and you can choose between warning, error, or ignore. There are many items listed here. It is recommended not to change them unless you have special requirements or are very clear about the function of a particular item. Otherwise, just use the default settings. Click OK, and then we can proceed to check our schematic. After running the DRC, we find that there are 11 errors. Let's take a quick look. This one indicates unannotated components. This one points out a power issue. Then there are unconnected nets and some duplicates. Since there are no reference numbers, all the resistors are flagged as duplicates. Now that we know what the problems are, we can close this window and fix them one by one. First, let's look at the annotations. For every error, it uses an arrow to point it out for us, which makes it easier for us to check. Let's first check and resolve the unannotated components. Click on Tools, then Auto Annotate. Set the rules which we've discussed before, so no changes needed. Then click Annotate, and finally click Close. Now you'll see that all the reference numbers have changed from LED 1 to R4. Let's click Save first. At this point, let's run another check. After running the check again, we see that there are 4 fewer errors, with 7 remaining. Next, let's address the power issue. For this kind of issue, we usually just need to place a marker to resolve it. Click on Power, enter PWR, mark it as a power source, and then click Annotate. Then rotate it, otherwise it will block the 5V. Place it here, and then copy one. Select the selection tool to copy this one for ground, and then let's run another electrical check. Alright, now there are 2 fewer issues. So now we have 5 issues left. Among these, 4 are unconnected issues, and 1 is that the drive pin is not connected. So how do we solve this? First, let's take a look at the situation. Pin 5 is the USB shield, and generally the shield just needs to be grounded. And since our USB is only for power supply, we don't need to use the positive and negative grounds. We can simply choose no connect for them. Let's see, where else is there? There's also pin 7. We already discussed this in the previous episode. Since the 4511 doesn't have the drive enabled, we don't connect this pin. Alright, you can also remove that, and then let's run another check. Great. This time there are no errors or warning. With this, our schematic design is now complete. In the next episode, we can introduce some PCB related knowledge. That's it for this episode. If you enjoyed this video, please subscribe to my channel for more content. Thank you everyone.